Welcome to Lab 8. This is going to be a shorter video. All you're going to learn here is how to perform integration and a little bit about antiderivatives. So let's begin with just how to perform basic integration using Mathematica. The first sample asks you to evaluate an integral, and this is an indefinite integral. And I know that because it does not have an upper and lower limit on my symbol for integration. And remember, integration is just the process by which you undo taking a derivative. So if you start with a function and you take its derivative, integration is going to start with the derivative and help you figure out what the original function was. In the case of indefinite integrals, we can't be 100% sure what that original function was. And so we introduce a constant, a plus capital C. We'll talk about that in a minute. There are two ways you can enter integrals into Mathematica. One of them is to use the integrate command. Inside the square brackets, you type in the function you want to integrate. Nothing unusual there. And then you put a comma down and put the variable that you are integrating with respect to. And if I hit Shift Enter, that's the function whose derivative would give me my original function. And one thing you'll notice here on the output is Mathematica does not put a plus C on it, but there really should be one, because if I had a constant on this output function and I took its derivative, that constant would disappear. Here's what I mean. All right, very quickly, I just stored my last output as a function, and then I took that function's derivative, and you can see that this output matches, although it's reversed, so we could do this. It matches what was in my original integral. But what I'm trying to say to you is there might have been a plus 4 here in my original function. And when I run the derivative command, I get the same function. Or maybe there was a minus 100. Again, take its derivative and that constant's going to disappear. And that's why you were taught in calculus class that you would put plus a capital C there. You don't need to put the plus C into your lab, but if you were to take this answer and write it down on paper, you would add the plus C at that time. The other way to evaluate an integral is to use the integral symbol. In your basic math assistant, you're going to want to click from the basic calculator tab to the advanced, and here you can see you've got your integral notation. I'm going to choose the first integral symbol, which is the indefinite integral. One thing you'll want to note is you do want to keep your function, if it has multiple terms, inside of parentheses like you see me doing here. And obviously, the command worked. Now, the only difference between the indefinite integral and the definite integral is the definite integral actually calculates a number for you. Remember, the definite integral represents the area under the curve, in between the function and the x-axis, between whatever x values you specify. And as far as commands go, you've got the same choices here. You can go back to the integrate command. And this time, instead of just putting x at the end, you're going to do set brackets, put x as your variable, put your lower limit of integration and your upper limit of integration. And I get a value of 104/3. If I do the basic math assistant, I'm going to move over to the second integral, which has the boxes for upper and lower limit. Again, just make sure you type the right values in the right places. And you can see it's not happy because I forgot my parentheses. And remember, the way that you calculate this definite integral by hand would be to, first of all, find the integral, which was negative x cubed plus 2x to the 6th over 3. Then you substitute the top limit of integration in first, and you subtract what you get when you substitute the lower limit. Just a little refresher. Right, in this next sample, you're just going to make a table of the antiderivatives for the natural logarithm of a number multiplied by a constant from 1 to 5. Because we're making a table, we're going to use the table form command to make it look like a table, then put in table. We're going to put in the columns that we want to have. So I want to have the natural log of a number multiplied by a constant. The natural log, again in Mathematica, slightly confusingly, is capital Log. I'm going to put in a constant k with an x inside that function. And then in the next column, I am going to use the indefinite integral to show my antiderivative of this function. Close my set bracket. Then I need to specify what values k should take on, so I'm going to say from 1 to 5 in increments of 1. Close up my table command, and I'm going to put my table headings on. Now in the table headings, I'm going to go back to standard notation for the natural log, which would look like this. And then I'll just have a column for antiderivative. Now if you notice, my k values didn't show up. It's just k across the board. That's because in my original command, in between the k and the x, I either need to put a multiplication symbol or I need to insert a space. There we go. Now I've got my k values being applied. And again, the notation here is again a little bit less than pleasing because this capital Log, when Mathematica says log of x, it really means the natural log of x. And the antiderivative of that, you can see here. And the same for natural log of 2x, 3x, 4x, 5x. So that's a little bit about creating antiderivatives in a table.